this important result, without which I can't continue here. Okay, enough of that. Yes, Ryan, did you wanted to say something?
Oh no, sorry. I
No
had
worries.
to put my hand down.
No worries. No worries. Okay, so this is how we deal with all these infinite limits. And I would like to also discuss, yeah, for example, here, which degree is higher? Is the numerator higher or the denominator higher? Yes, Mallory, go ahead.
The numerator has
Sure, sure, which means all this rational function will go to negative infinity. Here, which degree is higher? The top or the denominator? Yes, Ryan? Yes, right, Manny? Okay, go ahead.
Denominator, I'm sorry.
No worries. So if the denominator has a higher degree, if the denominator has a higher degree than the numerator, where does the limit go when x approaches infinity?
Zero.
That's it. Good. So I just wanted to look at a radical function because they are a little bit more difficult, especially with quadratic functions. So let's take a look at 43. So I have limit as x approaches 2 from the square of x squared minus 9. Well, this is a more difficult situation because I have to find the domain of this function first. Forget about the limit for a moment. How do I write? What do I need to write? What do I need to do to find the domain of this function? And we discussed this function a few times. I have to plug in my device. Yes, so tell me, what do we need to write for this function to exist?
We said, oh, sorry, there's hands.
Yes, Rachel?
X squared minus 9 is greater than or equal to 0.
Excellent. No one, for some reason, no one likes the radical function. I found one person. Okay, maybe 3 or 4. Okay, but careful. This is quadratic. It's not linear. You cannot move 9 and take square roots. That's not allowed in a quadratic inequality. It's not allowed. You have to factor it or graph it. So forget about this. Can anyone tell us how does this look like? What type of function? I said it here, it's quadratic. But how does it look like? If you were to graph this, how would you graph it? Because we know the quadratic function either looks like this with a minimum or looks like this with a maximum. Which one is it? With a minimum or with a maximum?
Minimum.
Very good. Where does it cross the x-axis? X squared minus 9. It has to have two solutions.
I would guess -3 and +3.
Perfect guess. Of course, it's not a wild guess. It's an educated guess. Okay. And now please tell me, for which x values is this function positive or 0, meaning above the x-axis? Where is this function greater than or equal to 0, which means above the x-axis? For x values here and for x values here. If I choose anything here, it will be above. If I choose anything here, it will be above. But if I choose between -3 and 3, it will be negative. It will be under the x-axis. So now, how do we write the domain of this function then?
Bracket -3.
I have to start from left to right.
Negative infinity. -3. Parentheses. Oh,
It has to be bracket because it have the equal symbol. Yes. Union.
Another bracket.
Yes.
Infinity.
Very good. Awesome. And look now what they want us to determine. Where is 2? 2 is right here.
Since it's not in the domain, would it not exist?
Excellent. Excellent. Brilliant. Who said that? Brendan? Thank you.
Yes.
Perfect. Of course. That's the reason why I don't even look at this. I find the domain first. After I find the domain, because I know how to graph this function, and there are other methods you can use, I know how to graph. I know how it looks like. I know it crosses at -3 and 3. I know that it's above the x-axis here and here. That's the domain. And now when I look, okay, it's D and E. You could say, plug it in. It's 2 minus 9. It's 4, I'm sorry. 4 minus 9, -5. I know it's D and E because the square root of a negative number doesn't exist. Okay, but it is much better to find the domain first. Why? Here's the reason why. What if I say here 3 from the left? Let's say I don't want x approaches 2. I want x approaches 3 from the left. And you don't have the domain. And you plug it in, you will get 0. But it's D and E. Because it's 3 from the left. 3 from the left, the function doesn't exist. So that's why just simply plug it in may not work in all situations. This is the wise thing to do. Find the domain, as Rachel said, solve this. You know it's quadratic. Quickly you know the graph. You know where it intersects the x-axis. You find the domain, and now you have no difficulties in determining that limit. Okay, enough of that. I see there is something. I have to go. Okay. So let me go back. Now I would like to talk about continuity. Okay, so that's the last part of this section. What does continuity mean? When is a function continuous? I think I am on page 8. Continuity. Okay, so here's an example. You see what I did? I graphed this function without raising the marker off the paper. Yeah, I have to, and because I want to put arrows, but there was no gap. This function is continuous everywhere. Here's another function. And here is I raised marker off paper and I continued. This function is not continuous. It has an infinite discontinuity at 0. Okay, here's another function. Raised. This is called a jump discontinuity. And there is one more. Here's another. I still had to raise my paper, a marker of the paper because I had a gap here. A hole, I should say. This is called removable discontinuity. So here you see the limit from the left is -infinity. The limit from the right is +infinity. Here the limit from the left, I don't know, is 4. The limit from the right is 6. But what happens here? Here the limits from either side are the same. So this is at a. As x approaches a from the left of f of x equals limit of f of x as x approaches a from the right. But they're not equal with the function value at a. So the limits are the same. The tendency is the same on both sides. So the limit from either side exists. So I can even say the limit of f of x as x approaches a from either side is a number L. Exists. But the L does not equal the function value. So that's why this is called removable discontinuity. And only for the removable discontinuity, left and right limits exist and are the same. Okay. Any questions on when the function is discontinuous? Now, one very, very, very important concept, is continuity at a point. I just wrote it. The limit from the left has to equal the limit from the right and has to equal the function value at that point. So this function is continuous at this point because the limit from the left, the limit from the right, and the function value, they all three exist and are the same. So what is the definition again? Limit from the left equals limit from the right equals the function value at that point. Super important concept. Okay, so let's look at an example and then hopefully we can continue. Okay, is this function continuous? Mallory?
No.
It has a jump discontinuity. Is this function continuous? Anyone else? Kimmy? No, it has a
No.
infinite discontinuity. Is this continuous? Of course.
Yeah.
I start here. I do not raise my marker off the paper or pencil or whatever. This is continuous. Okay, where is my page? Okay. So these are all based on graphs. I think we are okay with that. So is this function continuous at 3? No, it has a jump discontinuity. Again, we've beat this to the ground already because I wanted to move on. Graphing piecewise defined functions, we can do any of that. But I just want to choose something like this. And let's see, are we asked? I just want to check here if we're asked to graph. No, we're not. Okay, good. So we don't have to graph. We're asked, let's say 71, because it looks kind of weird. So let's take a look at it. I'm on page 9. Good. So in 71, I'm just going to copy it and 71 on 126. So g of x is x squared minus 3x minus 4 over x minus 4 for x less than 4, and 2x minus 3 for x greater equal to 4. Is it continuous at 4? Why or why not? Okay. So we are only asked to discuss, normally with my STEM class, I go through a different analysis, but here we're just going to apply the definition. So continuity at x equals 4. What has to happen if it's continuous? The limit as x approaches 4 from the left, from which function? Must equal the limit as x approaches 4 from the right, from which function? And must equal f of 4. Can anyone help? Anyone I haven't heard from? Please, anyone. I think I haven't heard from Simone and Jalen.
I did I answer the question?
I'm sorry, I didn't hear, so my apologies.
We plug in 4 for x.
So first I need to identify which function I write here and which function I write here, and which function I use for that. Who would like to help?
One says when x it's less than 4. So for the first one, it's gonna be x squared
Very
minus
good.
3x.
Yes,
minus 4.
awesome. That's all I needed. And I know, yes, Mallory, you wanted to say something?
Oh, you just said it. I didn't know if somebody's gonna answer. So
And for the other one?
2x minus 3.
And for this, where do I plug in 4? In which function? Yes, you're right, Ryan?
Wouldn't it be the 2x minus 3?
In 2x minus 3. Excellent. See, that's why I tortured you from the very beginning with this function and its graph, so we don't have to worry about it now. Excellent. Great job. Okay, so let's determine this. So 4 from the left. I know it's a little bit more difficult. Let's start with this one then. How much is this? It's a polynomial. We know how to address it, and I'll come back to that. So what is this number?
5.
Yes, 4 times 2 is 8. 8 minus 3 is 5. No worries. Perfect. What is this number?
7.
4 times 2 is 8 minus 3.
Oh, sorry.
Good. Okay. So it looks good so far. It's looking good. This is 5 and this is 5. But now we have to work on this. Let's take it aside. So limit as x approaches 4 from the left, from x squared minus 3x minus 4 divided by x minus 4. What do we need to do first?